Hey, this is Mr. Aiden. This is the 2022 AP Calculus AB free response question number 2. This was the second of the calculator problems. This was from the May 9th exam 2022. And let's get to this free response question. Check out my website, check out my YouTube channel, MrAiden.com. And you can see right away this calculator problem, they gave me two functions. They gave me f of x and they gave me g of x. And in my calculus class, we used the TI Nspire CXCAS. And so the first thing we do is we define our f of x in our calculator as natural log of x plus 3. We're going to define in our calculator g of x is equal to x to the fourth plus 2x cubed in the calculator, and that way we can take a look at that. And if you can see, we have an intersection right here. We have our f of x on the top right here. Okay, I'll do this in red, the f of x. You can see in the blue right here, we have, as best as I can do it, is we have our g of x. My bad, we have our g of x. And you can see they intersect right here at -2, right here at x is equal to -2. Well, what's this other intersection right here? I don't know what that is. They call it x is equal to b. And so what am I going to do in my calculator? I'm going to solve, I'm going to put in algebra, solve f of x is equal to g of x, comma x. And that tells me that b is equal to x is equal to 0.781975, and that gives me my upper limit there. Now what are we going to do? We're going to find the area enclosed by these graphs. We're going to take a look at this total area in here. And so how do we find area? We do an integral. What's our lower limit is -2. What's our upper limit is this b, this 0.781975. Who's my top function is my f of x minus my bottom function of my g of x, d of x. And that ends up giving me 3.60355, and that is the area underneath the curve. Enclosed by the graphs f and g. Okay, that was A. Now we go on to B. Remember, we have f of x on the top, we have g of x on the bottom right here, and we want to know the vertical distance at -0.5. Okay, so we have right here the distance between here and here. Okay, this distance. What is this distance? They said let h of x be the distance. So let's define what h of x is. H of x equals f of x minus g of x, doesn't it? That's the distance between the f and the g. And we want to know, is it increasing or decreasing? So when we take a look at increasing or decreasing, what are we doing? We're doing our first derivative test. The first derivative test. We're trying to find the first derivative of this. And so we are going to take a look at this first derivative, and therefore if we know h of x equals f of x minus g of x, I'm going to do h prime of x equals f prime of x minus g prime of x. And if we take a look at h of 0.5, sorry, -0.5, my bad, -0.5. We're looking at -0.5. I'm going to do f of -0.5 in my calculator minus g of -0.5 in my calculator, and I end up getting positive 1.10379. Okay, well, if we do the same thing here for the h prime of -0.5 equals f prime of -0.5 minus g prime of -0.5, I end up getting in my calculator f prime of -0.5 is 0.4, g prime of -0.5 is 1. That gives me -0.6, which means, do you see how this function, since this is a positive value, obviously we have a positive value of this difference, and you can see that rate is changing at -0.6. Therefore, the function is decreasing. This h is decreasing, and that is my answer. I'm using nice calculus principles in order to do it. Okay. Then we get number C, which is a letter and possibly a number. You can see we're doing the cross sections problem. Cross sections, we're doing squares perpendicular to the x-axis. So we have a square. You can see right here, this is going to give me a square three-dimensionally, and so you can see three-dimensionally there, and then we have a really small square right here, So think about what's the area of a square. The area of a square is this x times your x squared. That's your area. Therefore, we're going to do the volume. So we want to do the volume of this. So volume equals the integral of this x squared d of x. Or you can call it, we're doing this from -2 because we're doing perpendicular to the x-axis. From -2 all the way to your b value of 0.781975. And what are we doing? What is this x value? This is f of x minus g of x. That is this side, which means we're going to do the side squared d of x. And this is how you do cross sections of squares. If you don't know how to do this, take a look at my video on cross sections of squares. It's pretty easy. We get 5.34010, and that is the volume of our solid. Okay. Now to the hardest part of the problem, which is D. And the only reason this is somewhat difficult is we can think about this. It's just weirdly worded. It says a vertical line in the xy plane travels from left to right, and we know the vertical line is moving at a constant rate. And so we know this line is moving. Dx over dt is positive 7 units per second. And we're going to find the rate of change of the area. So let me think about what this formula for area is. What's the formula for area? Again, is your base times your height. Okay, so it is your f of x minus your g of x squared. That's your area. And we're going to find the rate of change of the area, which means we're going to take the derivative of this equation right here. We're going to take the dA over dt, which is the derivative of the area with respect to time. We're going to do the chain rule here. Okay, so we have 2 times f of x minus g of x to the first power times the derivative of the inside guy, which is f prime of x minus g prime of x. And because we're doing implicit differentiation, we also have to do dx over dt. I called it dx over dt. You could call it some other things, but it's really this change of this area of x squared with respect to time. Now we're going to plug in values for this. X is equal to -0.5. So we have 2 times f of -0.5 minus g of -0.5 times f prime of -0.5 minus g prime of -0.5 times dx over dt, which I called positive 7 units per second. And so if we think about it, I've already done some of this math earlier on. You can see f of -0.5 minus g of -0.5. I did this back in letter B. I also did this this f prime minus g prime at -0.5. And so I know these values is positive 1.10379. I know this value is -0.6. I know this is 7, which ends up giving me -9.271836. And what are the units of the rate of change of area? Would be units squared per second, because they told me this was units per second. That is the rate of change of an area with respect to time. Well, that was the end of the calculator problems. That's the 2022 AP Calculus AB free response question number 2. I'll calculate later. See you later.